AI drone swarms are rapidly redefining the way wars will be fought in the 21st century. Unlike traditional military assets that rely on human control or central command, these swarms operate using artificial intelligence, enabling hundreds of drones to coordinate, adapt, and execute complex missions autonomously. The concept is simple yet revolutionary. Place expensive, human-operated systems with large numbers of low-cost, intelligent drones that can perform reconnaissance, attack, and defense simultaneously. These drones can think, learn, and react faster than any human or traditional system. The U.S. military, along with global powers like China and Russia, is already investing billions into this technology, recognizing its transformative potential on the battlefield. At the heart of drone swarms lies decentralization. Each drone in a swarm is equipped with AI that allows it to communicate and make decisions in real time. This eliminates the need for a single point of control. If one drone is destroyed or jammed, the rest of the swarm recalibrates instantly. This kind of resilience and adaptability is something traditional systems cannot match. The swarm functions like a living organism, nimble, reactive, and nearly impossible to predict. In military terms, that translates to significant strategic and tactical advantages. Instead of sending a single hive, you asset into hostile airspace, a military can deploy 100 or more autonomous drones that can carry out surveillance, electronic jamming, or even strike missions, all while minimizing the risk to human life and capital investment. The U.S. Department of Defense has already demonstrated this concept in real-world exercises. In one notable test, the Pentagon deployed over 100 Perdix drones from fighter jets. These small, winged devices demonstrated the ability to fly in formation, adapt to new objectives, and continue functioning even when some units were destroyed. DARPA, the U.S. military's advanced research agency, is pushing the limits further through programs like Offset and Gremlins, aimed at developing swarms that can operate in urban environments or be launched from aircraft and recovered mid-air. The Air Force's Golden Horde program is also creating autonomous smart weapons that communicate mid-flight, choosing and adjusting targets on the fly. These aren't theoretical projects. They're part of a long-term strategic shift in how the U.S. prepares for future combat scenarios. One of the most compelling features of AI drone swarms is their ability to conduct saturation attacks. Traditional air defense systems are designed to track and eliminate a few threats at a time. But when hundreds of drones approach from multiple directions, varying in size and speed, those defenses become overwhelmed. Missile systems run out of ammunition, radars are confused, and decision makers are buried under a flood of inputs. The swarm essentially overloads the system, creating chaos and exploiting any weak point in enemy infrastructure. This tactic is not just efficient, it's nearly unstoppable with current defensive technologies. The sheer scale of a swarm, combined with its intelligence, makes it the ideal tool for neutralizing heavily fortified positions, mobile targets, and even naval fleets. Beyond sheer firepower, drone swarms bring speed to the battlefield. AI-powered drones can process data and make decisions in milliseconds. They can reroute around obstacles, select alternative targets, and coordinate their movements without human interference. This kind of rapid autonomy is vital in combat, where hesitation can cost lives. Moreover, the drones can use machine learning to adapt to changing conditions. If they encounter a new type of jamming signal or air defense, they can learn from the experience and alter their behavior for the next mission. This learning loop means swarms grow smarter with each deployment, something human-operated systems can't achieve at the same scale. In terms of cost, drone swarms are a game changer. A single advanced fighter jet, like the F-35, costs over $80 million, not including training, maintenance, or logistical support. A drone swarm, by contrast, might consist of hundreds of individual units costing a few $1,000s each. This makes the swarm not only more resilient, but also more expendable. If a few drones are lost during a mission, it's a small sacrifice compared to losing a manned aircraft or a pilot. This cost-effectiveness allows for wider deployment, sustained campaigns, and greater tactical flexibility. The future relevance of drone swarms goes beyond battlefield dominance. They're already being designed for multiple roles: logistical support, search and rescue, communication relays, and even cyber warfare. In GPS-denied environments, drone swarms can use visual or terrain-based navigation to find their way. In naval operations, they can act as early warning systems, flying ahead of fleets to detect submarines or missile threats. On the ground, micro-drones can enter buildings, scan urban environments, and identify threats with a precision no human scout can match. These diverse applications mean swarms aren't just a new weapon. They're a new platform, one that can support nearly every branch of military operations. Despite the advantages, drone swarms raise significant ethical and strategic concerns. Who is accountable when an autonomous drone makes a lethal decision? How do militaries prevent malfunctions or unintended escalations caused by misidentification? These questions are still being debated, but the speed at which technology is advancing means policies and international norms are struggling to keep up. Furthermore, as drone components become smaller and more accessible, the risk of non-state actors developing or acquiring swarm capabilities increases. Terrorist groups, rogue states, or criminal organizations could potentially use swarm tactics to carry out highly coordinated attacks with minimal cost. This threat adds urgency to the development of counter-swarm technologies, electronic warfare tools, and robust defense protocols. The international arms race for drone swarm supremacy is well underway. China has showcased its own large-scale swarm capabilities, including 48 drones launched from a truck and flying in coordinated patterns. Russia, Israel, Turkey, and Iran are all experimenting with autonomous drone systems for offense and defense. The global nature of this race means that the U.S. must continue innovating to maintain a strategic edge. Investing in AI research, building secure communication networks, and developing anti-swarm defenses are now as important as building new jets or tanks. Ultimately, AI drone swarms represent a profound shift in military thinking. The focus is no longer on a few highly advanced platforms, but on the collective power of many simple machines working together with intelligence and purpose. It's a form of combat that favors adaptability, speed, and scale over brute strength. As the technology matures and becomes more deeply integrated into military doctrine, drone swarms will likely become as essential to warfare as aircraft carriers and satellites once were. Their ability to operate independently, adjust in real time, and carry out missions with precision and minimal human risk makes them not just a tactical advantage, but a strategic necessity. The battlefield of tomorrow will be dominated not by lone warriors or isolated weapons, but by intelligent, autonomous collectives capable of responding faster, striking harder, and surviving longer. AI drone swarms are not just the future of warfare, they are the future of military thinking. Understanding, developing, and preparing for this future is not optional. It is the next step in the evolution of global defense.